Thank you. Morning, everyone. So let me explain. This is a talk in two parts. The background to this, I'm trying to be honest in advertising here. We're funded by Microsoft. We were given $300,000 last year to work with these lawyers. So this is the law department, Queen Mary University of London. And they're actually a very interesting bunch of people there. They're two professors of law who are actually practicing lawyers, and they're quite significant advisors to the European Commission on various things to do with data protection law, privacy, networking, and so on. A whole bunch of areas, and they actually act as lawyers in courts, in cases as well. And they've written a book a couple of years ago, published by Oxford University Press, called Cloud Law. I kind of recommend the book, actually. It's quite an easy read. It's aimed to say, what is the current state of law that applies to cloud computing? So the reason Microsoft got interested in us helping them is in Cambridge, we wrote a lot of the early cloud software. So if you use Zen, if you use Amazon EC2, then you're using our software. It wasn't written in America, it was written in Cambridge, right? We spun out the company that wrote that software. So we know a bit about cloud computing. That's probably more than Stanford University or Berkeley. So, and some of the people that wrote that software, which we did about 10 years ago now, they come back into the university and we're working on the next generation of cloud computing. So, Microsoft decided that they were interested in this area, and you'll see why, and you'll probably know why in a second. So the two bits of the talk, and the first bit is kind of about the general background about why, and then the second bit is sort of what could you do if you thought you wanted a European-only cloud, which is the question Microsoft asked us to look at last year. They said, if we had to devise a cloud that operated in all senses in Europe only, what would we do about it? Okay, but the first bit of the question is kind of why would you do that? Okay, well, obviously, the reason is surveillance. And the headline story last year was not just the Snowden bit of the story, but it specifically was the fact that that there was surveillance going on of the cloud, not just the internet, all over the place. And in particular, the story that really hit the headlines was Angela Merkel's cell phone being bugged by the NSA. So at this point, one of the responses from the German government was to tell Deutsche Telekom, was it be possible to have a kind of Bundes Internet or Bundes Cloud or whatever you would call it, that would be a German-only cloud, because they were fed up with this, right? And in fact, of course, it's illegal. I'm surprised they didn't arrest the American ambassador, actually. They would have been well within legal rights to do so. They could have said, you're a representative of America, you're in Germany, your government is spying on us, that's a criminal offense in Germany. You go to jail until your government actually fixed it, right? They could have done that, but they didn't. They're polite, I suppose. They wanted to resolve this in a more friendly way, which they still haven't. But anyway, so and in fact, I'm just going to kind of give a reaction here, which is something I was involved in the 90s, which is we've actually been in this situation before about governments wanting to do surveillance. In fact, we heard yesterday that even in this very civilized country we're standing in here, the government wants to kind of weaken all the crypto and survey on us again. This actually happened in the 90s, and I was on the Internet Architecture Board for like 6 years in the late 90s. And one meeting, we were in Washington, DC, the IETF meeting, Internet Standards meeting, and we were asked, could the government, the US government, asked, could we weaken all the crypto so they could spy on everything under various laws, including Calia? They wanted to basically have weaker crypto, backdoors in crypto, escrow the keys, all the list of stuff you see today happening again. We actually, as the IAB, a bunch of us went to the White House. I didn't go, I'm not a US citizen, so it wasn't kind of my business at that point, although I thought actually this kind of, well, there is an international perspective. The internet is not an American thing. Most of the internet is outside America nowadays. There's a lot of it in America, but a lot of it's not in America nowadays. But anyway, there was some frank exchanges of opinion about this, and actually we wrote an RFC. And John Postel, who was the guy in charge of RFCs, was the editor, actually was a very smart, very funny guy, and he used to keep back numbers of RFCs for special reasons, for special events. And so he gave us this number. which is 1984, which some of you will know the literary significance of 1984, which is the response to the US government asking the IETF to standardize bad secrecy, bad privacy, bad crypto. And it was like, not really, we're not going to do that. So, you know, the attacks the government in America wanted to do at that time were explicit. And we said, no, this is a bad idea. Of course, there's a long list of why it's a bad idea. You know, one obvious reason, the editor of that document, by the way, was an Englishman called Brian Carpenter, who was head of the IAB at the time, and was from IBM. And he actually said, you know, this is a stupid idea because the American government doesn't get to say what happens in other countries. For example, at that time, for the public in France, it was illegal to use any encryption, right? Since Napoleon, using crypto tech, you know, had been forbidden. Of course, now it's okay to use it in France. But at that time, that was a very different policy than in some countries, where it was mandated to use decent encryption for certain kinds of activity because, you know, you really don't want to reveal certain things to people. There might be government secrets or there might be trade secrets. You don't want other countries stealing. In fact, I remember around that time I was working, doing some consulting with Hewlett-Packard, and we were told if you travel in France, do not use the telephone to discuss HP business, because the French government will intercept your phone call and give all your data to one of the French competitors of Hewlett-Packard. And that's not a crime, that's the French government's job. Right? This is no different than, for example, also around that time, the Chinese would routinely copy technology from Cisco, and hand it to Huawei, and people say, but you're breaking patents. They go, no, we haven't signed the World Trade Agreement. We're not breaking any law. It's inside China, it's okay. Is there any problem if you try and sell the stuff outside China? Of course, once they start to try and sell stuff outside China, they had to start signing World Trade Agreement and then respecting patents and so on. So that, you know, but actually you have to think about these things. Law varies, there are jurisdictional variations. And there are other reasons why this escrowing keys and weakened crypto is stupid. If you've already got strong crypto, you've already got PGP, you've already got tools that are quite good, then people go, oh, that's fine, I'll use the weakened crypto, but inside the weakly encrypted stuff, they'll encrypt strongly. And you'll have to decrypt everything to find that out, and then you won't be able to decrypt what they're saying, and you lose, right? So what was the point, right? You can't put the cat back in the bag, it doesn't work. So it's a stupid idea. And then there are lots of other reasons, of course. Around then, perhaps it wasn't so obvious, but it was obvious to us, you know, futurologists, people working in the IETF then, I've been working in internet stuff since 1980. It was obvious this was going to be the main way people did business. If you bought something, you bought a ticket for an airline, you would give your credit card over the net. And if you didn't have decent crypto, if the government weakened crypto, the mafia would get your credit card. And you know what happens? Yeah, they get them tens of millions at a time, and it costs a fortune, right? It costs a fortune which is not recovered by the credit card companies who cover for that eventuality at the moment. If you systematically weaken encryption, then the credit card companies like Visa, MasterCard, whatever, Amex, they will stop accepting liability. They'll just go, nah, it's your problem. We can't guarantee anything on the net because it's stupid, and you won't be able to do any useful transactions on the net, right? That will be the end of being able to buy stuff off Amazon on the net, be able to do your internet banking, because it won't work. And so this is clearly turns the internet into a useless tool for the purpose of ordinary commerce. We're not talking about terrorists here organizing attacks or stuff. We're just talking about most people and most of the useful value of the net. So we said all that. We said it's a really stupid idea. And at that time in the 1990s, we thought the IETF had won this argument. We also thought that we should prepare for the worst and do some more stuff. So we started kind of going, well, let's work on transport layer security and fix the, you know, actually fix the crypto, because IPsec, we realized had probably been compromised. The guy in charge of IPsec originally, right from the beginning, worked for the NSA at the time, and we were like, well, we're not really sure this stuff works properly, so let's do transport layer security. It's probably a better way of doing stuff. And very smart people like Eric Roscoe and whoever built this quite good infrastructure. And it has problems, but you know, that was quite good. And we also started work on DNSSEC and certificate agencies and all that stuff, which took rather too long to get out there. But you know, it's slowly happening. Certificate authorities and so on. And then just generally thinking better about crypto, so lots of groups started getting excited about not being pure academics working on crypto, but actually being people that could work on something have an effect. And then securing the infrastructure itself, you know, hardening routers and links and so on would seem like a good idea. Embarrassingly, this was all a bit slow in getting deployed. And one thing I was involved in, another thing I was involved in, which is very embarrassing, a small New Zealand company called Endace, they actually built this box, which is it's a little box, sits on a PCI bus, and can run, this is like, we're talking like more than 15 years ago, could do 10 gigabit per second full packet capture and deep packet inspection. Why? Because in New Zealand, they were a long way from anywhere, and they wanted to be able to assign the costs of traffic to each of the customers inside New Zealand for international traffic. So the New Zealand government paid this small group in Waikato University to build this box for the purposes of billing. Quite reasonable, right? And then I was working with them because we were also using it in the US with Sprint, which was one of the big tier 1 providers in the US at the time, to measure the traffic matrix on their network and also to characterize application traffic patterns so they could do just-in-time provisioning. Again, a completely reasonable thing to do, right? You measure all the traffic, you figure out what the traffic matrix is, you figure out what the source models are, and you build traffic engineering models, and then you fix your network, and then as you hit reaching some load point, you say, now we need to add more capacity, you need to light up more wavelengths or whatever. Okay, so Endace, built this stuff. It was pretty good. A lot of other companies like Arpanet and so on started coming along building other similar boxes, but this was like the state-of-the-art stuff. And then Ian Graham, who was the CTO at the time, discovered that most of the boxes, the biggest customer was a no-name building on the DC Beltway Bandit area. And basically, the largest customer for these boxes was the NSA. And what they were doing, which may not be completely obvious to everyone, some people here will know, is they actually had port mirrors on the internet exchange points. This, at the time, this would be like fixed east and west in America, London Internet Exchange, now London Internet Neutral Exchange. They had port mirrors which mirrored every single packet down a fibre to big buildings somewhere or other. In the UK, this would be GCHQ, and all the traffic would go there into a room full of these Endace boxes, which would actually, in fact, just tag the traffic initially, the initial TCP packet reassembly, tag the traffic, the few port numbers, a few other things, so you could index it and write it to network attached storage. So then you could later on analyze it. Okay? So that's kind of the architecture of a spy box, basically. That's a bit embarrassing. But anyway, the response, once we realized this was happening, sort of around 15 years ago, the response is, well, perhaps we ought to do more HTTPS by default. Of course, that's taking a while. I think Netflix just finally decided they're going to change over defaulting to HTTPS. But a lot of the cloud service, the sort of service type environments like web-based mail and so on, are HTTPS by default. So that kind of hopefully mostly fixes it, modulo the fact that we know TLS had, at least in one major implementation last year alone, 50 reported vulnerabilities. It's kind of bad, but they got fixed, they did get reported and fixed, and it is getting hardened and so on. Okay, so, but then also the world started to change. So tapping the net, as you start to do default security in your transfers, tapping the net is not really a very good way of getting at who's talking to whom and what are they saying. You might be able to get the traffic matrix, but you start to lose what's actually going on inside the packets because they're encrypted. And it's a lot of work to decrypt everything, to figure out, oh, this stuff's even encrypted inside the encryption. Oh, wow, what are we going to do about that? Fire up some magic quantum computer or something. But anyway, but the world also changed because, of course, then very large numbers of sites become natted, and the nats are dynamic, which means your traffic matrix information starts to be quite bad. If you're port mirroring from internet exchange point, you don't know what the edge traffic was, you don't know what the address translation maps are, and the ISPs aren't telling you because they don't log them either, necessarily. They may be just running a distributed algorithmic way. You can't reverse engineer it from the middle of the net very easily. So, and of course what also started to happen, let's say 10 years ago, is we not only have natted desktops and laptops, but we also have mobile devices. Clearly this is starting to be the dominating way fairly quickly that clients get at the net. And so you move from a world where you had a number of fixed IPv4 prefixes accessing from homes and offices and universities, accessing a relatively small number of big sites, to 100 million natted desktop workstations and so on, and 100 million websites, to 1 billion smartphones, or more, probably 2 billion now if we count China mobile, 500 million and so on. But what now happens, of course, is instead of accessing 100 million websites, we now go to a really small number of cloud providers. So where is the attack surface you should be looking at if you are the NSA? It is no longer intercepting all the traffic into the exchange points in the middle of the net, which doesn't really tell you who's talking to whom at all, or what they're saying. It's, let's go look at this small number of cloud service providers. The webmail providers, the social media providers, the video streaming providers. You know, I have a joke about this, they're probably only ever going to be 26 cloud provision, different cloud providers. Why 26? Because basically, if you look at your browser and you hit one letter, you got N, it goes to Netflix, and you hit F, it goes to Facebook, and it's autocomplete. You've only got 26 letters in the English alphabet, which dominates most of the websites, right? So this is a joke. But the point here is, if you were the NSA, instead of having to do, you know, map millions of natted endpoints, you go to one of those 26 sites and you figure out a way to get in there. And what is that way to get in there? You go with a special magic secret court order that says, you're going to mirror traffic off your disks to us, please. And if you don't, you'll go to jail. And we won't even tell anyone we did this to you. So that's the Snowden revelation, right? Okay, so, you know, it's really easy to find where the data centers are that implement the cloud, even though some of them are somewhat replicated. There's a primary set of services. Most of them are nowadays, you know, next to some big hydroelectric dam in the Pacific northeast of America, or northwest of America, sorry, or actually north of here, where the climate's good for keeping things cool without spending energy on cooling things. Actually, right here, I hear people have done that here very nicely. And in fact, what you do is you go to electricity companies, say, where are the really big bills going to? And you go, oh, look, there's a data center there. That must be a place we need to tap everything off of them. And actually there are some embarrassing things here. There's some embarrassing lack of practice that was not very sensible. So, yeah, so you can find these small number of data centers. You don't really care that much about the fact that, say, YouTube has lots and lots of caching sites. You care about the primary sites, you know, the really big places where everything gets centralized and backed up from, and all the indexing gets done and so on. And embarrassingly, all this data in those sites was being kept in the plane, it's stored on disk in the plane, even though, you know, it's going to be moved to people over HTTPS. There it is, so that, well, we'll talk about this in a second. And it's actually transferred between data centers in the plane. This is the most extraordinary thing. It's like most of the NICs in fast machines in data centers actually have TCP offload and crypto offload nowadays. So why were they not encrypting stuff between data centers at the time? I'll take questions at the end if that's okay. Unless there's a clarification.
It's a very brief thing. So not only the data processing thing, but probably also a lot of no source authentication, right? No source authentication, so where the transfer stuff is.
That's between data centers. That's not so much a problem. But yeah, I mean, because at least the data center providers harden their own data centers, and they know that there's not spoofing going on. And IP spoofing is if you're a data center, you go to an ISP, you say, I need a bunch of prefix, I've got my own AS, I'm going to have big fire hoses of traffic. You get a very different interface to the world than a small customer. So the thing I was just pointing out is that if you wanted to spy on the data center provider, you know they're mirroring data because of reliability, high availability backup. You don't even have to use a legal trapdoor into them. You can just literally go and white-hat the stuff going on the fiber between the data centers. You just port mirror that, and you get everything. Well, then, a couple of years ago, you would get everything from them that way. Although actually the NSA didn't have to bother doing that, they could just go in with a big court order and say, we're going to pull everything off you directly. And then this last point is data is processed in the plane. Of course, we've had a couple of presentations yesterday about diff-priv, but also homomorphic encryption. There are maybe in the future techniques to avoid that. But okay, why is the data kept in the plane, transferred around the plane? Well, transferring around the plane is stupid. Keep it in the plane is because the primary business model of at least Google and Facebook is analytics. And so your data is, you know, the product, and targeting ads to you and doing analytics so they can sell information that's essentially market research to lots of people is a primary goal. So if the plane's encrypted, they have to burn extra cycles all the time to do clever stuff with it, to do these clever analytics, right? All these kind of machine learning things they use to figure things out will become somewhat more expensive. Not intractable at all, but somewhat more expensive. So the naive way to do it, you decrypt it, you run all your analytics, you re-encrypt it again, and then the window of opportunity for the attack of pulling all the data out there would just be during that processing period, right? If you're going to do it at the data center level, would be, would much reduce the risk there, but would cut up the cost. So you can see why they didn't do that. Why they didn't encrypt between data centers is just plain stupid. I mean, that's just, anyway. So that business model, what we call a two-sided business model, where basically you give a free service apparently to customers, free Gmail, free Facebook, free Dropbox, whatever, but actually the reality is the exchange is the customer wastes eyeball time and handset energy and latency by getting this remote service, and the customer's data is being resold without the customer actually having it. They're not a customer anymore, they're the product, as Zuckerberg famously said. But that sort of allows the NSA to weaponize this system, right? That business model. So it's fundamental, and if you want to go in and say, well, we're going to stop you doing all of that, you'd have to come up with a good argument to Google about how are people going to pay for the service, not with idle time and you selling analytics, but they'll just give you money. That might be okay, right? I mean, how much do you think it would cost if we just paid for all those services instead of using advertising? I can tell you the answer. We actually did the analysis. You look at Google's profit, you look at the cost of running a data center, it's about $3 a month per person. So you could get Facebook and Google without ads just by paying $3 a month. So imagine your ISP just added that onto your broadband access bill. Would people complain? I mean, they don't care about privacy, but they might care about their battery life on their phone and the latency and, and the annoyingness of ads, time wasted. So, you might imagine that being one model. Anyway, moving along. So, the interesting thing about the Snowden revelation was the IETF response was actually, the IETF is kind of, I'm going to channel this IETF model, right? Some of you might get this if you don't ever been to the IETF. There was an IETF in Vancouver, which is obviously not in the US. It's in Canada, which is slightly more civilized in some ways. But a lot of the people there had this is a year and a half ago, I guess, had this like really outraged response. It was like, what the hell is the US government doing this? This is the internet. It's global. We're for freedom and privacy and all this good stuff. And so the kind of typical IETF tech geek person is somewhat of a sort of West Coast ex-hippie libertarian, which is not really hippie. They like making money. They think capitalism is good, but they really don't like governments, right? So this is not good. The excuse that we might catch terrorism is poor. If you look at the evidence, did they actually catch any terrorists using all this surveillance technology? There is none. There's literally zero. There are a few cases where they produced evidence in a case after they caught somebody, where they caught the person because a policeman saw somebody acting suspicious by a car in New York. Right? But there are no cases where somebody has been actually prevented from something as a result of NSA and GCHQ surveillance. There isn't one, by the way. So this annoys people who don't think the government should be doing that kind of thing without a pretty hefty example case that shows a cost benefit. By the way, there's another cost benefit analysis. There's quite a good Cato report. The cost the NSA is running to do all this surveillance is about 1,000 times per life lost in 9/11 that you would spend in saving a life in an airplane incident. So typically, if you want to fix a plane so it's safer, like put an extra pilot in the cockpit, or you want to fix a car so it's safer, like force people to have airbags, then the cost the automotive industry and the aerospace industry is about $3 million per life saved. That's roughly what they spend. And the NSA is running at about $3 billion per life saved, except they didn't save any lives. They didn't even prevent one life being lost. So their justification is pretty rubbish. So if you're a libertarian and you think that's a good argument, or you're just a common sense, democratic person who think privacy is reasonable, then you might think through that and say, why are governments asking yet again to escrow all the keys and weaken the crypto? Sorry, give me an example who you'd have caught. Now there's possibly some evidence that Charlie Hebdo thing might have got prevented, maybe. I haven't actually seen a good story about that. Anyway, so there was a lovely story in the ITF in Vancouver. There was an open mic session. People just go up and say stuff. And Wes Hardacre told this story about why is surveillance bad for society anyway, once you know it's happening. And he said, well, here's an example of how chilling it is for normal social intercourse, just interaction between people. He was in San Francisco in the airport, about to fly up to Vancouver, 5 a.m. in the morning, waiting for a 6 a.m. flight to Vancouver to get to this very meeting. And he texted his wife, his partner, to say, this airport is so dead. What he meant, of course, at 5 a.m. is that it was very unlively, it was quiet, there were no people around. And he suddenly realized, after he hit send, that there could be guys with M16s pointing at his head 3 seconds later, because they might have interpreted what he said as being, he's about to blow up the airport, right? Why should he care? Why should he have to care about that? It's kind of obvious he is not that guy who's going to blow up the airport. He has no goods to it. He has no track record of it. If they were decent surveillance people, they'd have been noticing he just walked out of a mosque carrying a bag full of weird stuff which he'd ordered on the net from some fertilizer shop or whatever, and they'd have got all that information from proper intelligence, like humans rather than SIGINT, as it's called. Okay, so anyway, after all this, some things changed. And we actually, some of these things we've been actually kind of talking about, although in the CloSe project, the idea of the cloud running security services is slightly different than what I'm talking about here. This is the cloud itself secure for its own customers? But so anyway, immediately a number of the bigger providers were so embarrassed that this had challenged their libertarian feelings that they encrypted data when they shipped it between data centers. Wow, brilliant. That's kind of easy, right? It's a kind of no. But in fact, this is typically just the backup archiving data, so it's not that big a deal. It's not a lot of work to do that. Encrypting data whilst stored, many of them started to do that. So just take the hit on the computational cost of decrypt before you do processing, and that at least reduces the attack surface. It certainly reduces the accidental loss as well. Depending how you do your key management, and people here know much more about that than me, as long as you're cautious about keeping your keys somewhere else, which hopefully you are, there's not a lot of point in encrypting stuff and leaving the keys on the same disk in the plane, would be really dumb. But then if you lose the disk, you sell the disks, or your company goes broke and somebody else gets the disk, right? They don't get the data, okay? Modulo, the interesting European legal point actually, in European law, storage is called processing. If you look at data protection law in Europe, the word processing includes passive storage. So technically, legally, if you have a copy of data, even if it's encrypted, you're processing that data. And if you're not supposed to under data protection law, you're breaking current European law. So that's the only legal lesson I've learned in this, is the European law needs to change, because obviously for computer scientists, processing, it's storage. But anyway, just unfortunate phrase in the law there. Okay, so we went to encrypting many cloud providers started encrypting stuff while stored, and that's a big improvement, even just for accidental data loss, right? That's good idea. Would be nice if Sony did that with account information, right? It would be less likely hackers would be able to pull that data out. It would be nice if everyone just did that routinely with stuff that's sensitive personal information. And even on your own laptop, right? Obviously, you lose your laptop, you lose your smartphone, you would hope routinely everything's just like that. It's sensitive data, it's just encrypted and keys it on it. Then Apple actually did one step further, which is they moved to client-side decrypt for some of their services. So that's really nice, assuming you trust the client. Apple probably have a slightly better claim to secure client than Android phones. But somewhat better, but there still are vulnerabilities. But it's still a lot better. So you move data from the iCloud to your device, and then you decrypt it, and you do your key management in some nice way, as yet unspecified and so on. The last thing, what I think is like, we call the holy grail is doing crypto on, doing processing with encrypted data. So homomorphic or garbled circuit, all these techniques. We heard yesterday about a couple of specific techniques where you limit the types of functions you apply, and you can do things. So MyLab from MIT, I think, is one of the systems that currently allows a relatively limited amount of processing of quite useful kinds. So if you just, for example, want to count occurrences of some string in something, then you pre-assign the strings you want to count, and then you compute the homomorphic function to do that counting over a set of encrypted data. That's doable, quite expensive, but not intractable at all. So that's quite attractive if you were just picturizing stuff. You want to count occurrences of strings that happen to be URLs. Could do that. You could do that on encrypted web pages. Okay, lots of stuff has to still happen. Better ways of securing key distribution, better ways of affordable working on encrypted data. Doing analytics in trusted third parties. Again, yesterday we heard about some of that. In fact, the F-Secure work, to some extent, is a version of doing some of that kind of thing. The analytics they're doing is, malware scanning and stuff like that. All good. It's like, and those are clearly useful things. Doing that in a privacy-preserving way doesn't necessarily have to run on encrypted data. It has to move encrypted data to someone encrypt, but do it on a trusted third party who doesn't have a bad incentive. So there are two ways you could do this, which would be sort of EU-only cloud, and one is you move it to someone who does the processing within the EU, or how about this? And we talked to cloud providers, commercial cloud providers, Rackspace is one quite big one, and they said, you know what, we would write a contract with customers. They were talking mostly about business customers, not domestic customers. They would write a contract, and you just say what legislation you want the contract to apply. So if there's any dispute, it would fall in that particular jurisdiction. And they're quite happy to write one that says Germany, Finland, UK, US, whatever. And then you have a dispute under that law. There is an issue with that, which is, of course, the whole Snowden story is about secret court and coercion in the US. So if the company has a footprint in the US, you end up with this nightmare. Microsoft is currently in. They have a warrant served on them by a New York judge to reveal Hotmail, actually for an okay legal reason, but it's a US warrant. Unfortunately, the account is a European account held in a Hotmail server in Dublin. So if they reveal this data, they definitely break the European Data Protection Law and will be fined. If they don't reveal the data, they'll be in contempt of court in the US and they will be fined. So the correct solution for this immediately would be the US judge to be fired or to realize he could serve a warrant in the European law. He can serve a European warrant. And this is no different than extradition. But unfortunately, it's a bit too obstinate. You know, it's a special pleading by the US. Right? Okay, so that's a bunch of stuff, so that's a bunch of stuff that we learned from this. And we wrote a long paper about all this, and there's a whole bunch of legal background. Interestingly, in this project, we were very lucky. Not only do I have just to name check people, Christopher Millard, for example, is a professor of law, but also Kwan and Jack Singh are both people with PhDs in computing and fully trained lawyers. And I have no idea why they're working on our project. I think they must just think they're trying to save the world. But because they could go and get incredibly well paid in many, many places. So we're really delighted. And they wrote this quite nice tech report. We have two papers about this actually. One's on SSRN, and if you're interested, email me about it. Okay, but let's say we want to implement regional cloud, so EU-only cloud. Could we? And I'm going to kind of indicate that technically we might be able to do an EU-only cloud, but actually I think I prefer just securing the cloud properly would be a better thing to do. And then having contracts that say what jurisdiction things happen under. And also just to drop into sort of security speak, the threat model for the NSA, you cannot evaluate the threat. You have no idea what resources they have, so actually we can't work out what the defense should be. Plus they have secret courts. Right? So we have no idea what to do about that. We don't know what powers they can invoke. So we should at least restrict ourselves to what are the sensible threat models. And actually for me, weakening crypto and escrowing keys in dodgy places is really stupid because that creates a threat model which is criminals, who there are lots of. Insider attacks from in our country, in the UK, we have like the NHS, the big employer, the health service, the biggest employer in Europe. Amongst 500,000 people who work there, some of them are going to be bad. They're going to be bribable or threatenable or just bad. Routinely it happens. They try and get a celebrity health record, right? It just happens. So we need to defend against that threat model as well as the mafia or blah blah blah. Okay, but could we build a regional-only cloud if you thought that was the solution? And kind of the answer is, well, it's difficult to say exactly. There are all kinds of things you could try and do, but it's all about management and control of where data is stored, processed, and how it's networked, and who you trust to actually do all these things. And the number of stakeholders in cloud plus ISPs is pretty high. I mean, the average number of ASs you traverse today, typically going to a given cloud service, you might go over 3+ ASs. You might go over 7, 8, 9, 10, 11 hops. That's less crucial, but actually a cloud service may involve multiple other parties, particularly if it's running analytics and targeted ads. I think we looked at the Times of India. When you look at the web page, you actually get on average 113 TCP connections, only 6 of which go to the Times of India. The others all go to different advertisers. So they're all stakeholders in this security model, and you don't know where they are, right? Who knows where they are? They may be advertising. They may be noticing you're looking at the travel webpage of the Times of India, and you're looking at the bit that's about London, and they advertise a sari shop in London. Okay, so what would you do to regionalize the cloud? You need to figure out where traffic goes. So can you do network level control of where the traffic goes? Yeah, probably. You can provision where cloud services are. Most cloud services do have, the first thing you contact is a load balancer, and the load balancer assigns you to some server somewhere or other. The easiest example is YouTube, where they have, Google have servers everywhere. Pretty much every country has some kind of YouTube caching service somewhere near you, and any popular content, you'll be redirected to the regional one nearest you very quickly. Many services have like Akamai load balancers, or whatever. So there are ways of provisioning cloud that might help with that. There are other ways of provisioning cloud that might also do isolation if you believe the isolation properties of virtualization properly. I'll talk a bit about that, and then you might obviously doing crypto everywhere is my preferred solution, and then you might do data tagging and information flow control to enforce or at least detect information leakage. So I'm going to talk about each of these things in turn. Firstly, we have control over where data goes in the internet to a very coarse-grained level. ASs within Europe, it's probably somewhat better than in North America. At one level, many European countries have national ISPs, which used to be our telcos. That's not always true, but certainly in France, Spain, Italy, Germany, UK, have at least one big ISP which physically constrains where the traffic goes on its national backbone. There are a lot of other ISPs, but at least one you can pick that will nationally limit where your traffic goes. So you might think that. But it certainly, if you're on BT's network in the UK, your traffic on their network goes where it stays within the UK link. Unfortunately, if you're accessing it, let's take a really stupidly simple example. If you're on a train from London to Edinburgh and you use the Wi-Fi on the train, your traffic goes via Finland, because they use a mixture of UMTS and satellite. They're very cunning. They have a VPN over UMTS to somewhere, happens to be in Finland, because the provider got the deal to do this, happened to be based here. And then those guys have a satellite uplink and a proxy, transparent web proxy, that looks at the things you're getting at, and if you get on a large object, they route it over a high-bound satellite link, because the latency doesn't matter for downloading a big thing. The throughput matters. And it gets it off the link back to the train over the 3G. Pretty cunning. Yeah, so you think you're getting at a website that's in the UK, but actually it's going on this bizarre route, right? So there are lots of leakages like that. In fact, there are many examples. If you're in Dublin, you can actually get internet TV from the UK, because the UK doesn't include the Republic of Ireland, but it sort of leaks there, because it's hard to stop stuff going across the border from the north to the south, right? Okay, so, but you could do controls, and big data centers actually have some explicit control over policy routing, so they are typically, they have their own AS numbers, and they can actually do BGP policies to manage where traffic goes. So that they could, at least in principle, use that as a coarse-grained way of controlling things. It would potentially lead to a lot of policies, and BGP doesn't scale well if you start to inject all kinds of magic tricks with clever attribute tricks or AS path prepending to stop traffic going this way rather than that for each customer differently. That would start to be pretty nightmarish, and I suspect the BGP infrastructure is already fragile enough it might be a disaster. So perhaps not the best of ideas, but it could work. Obviously, we can do provisioning within the cloud, and you've got these front ends that do load balancing, and then you have all these different levels of cloud service space. Software as a service, platforms as a service, infrastructure as a service, and you can decide where you place each of these. So clearly, you can dynamically provision something for somebody, and you can make sure you geolocate where that person is, if you believe where you've geolocated them. They're not doing some magic layer 2 VPN magic, so they appear to be somewhere. Like most people in the US who got BBC content from the UK by pretending to be in the UK by having a UK VPN server. Anyway, we talked about this for Netflix the other day as well. But you could help do this. And you could constrain their software, so I said most of that. And then you've got some kind of isolation property, so if you're running a cloud service for one person rather than another, then you've got some notion that each person's getting this service on this server, in this data center, and in this jurisdiction, maybe. We're working on something I'm just going to allude to here. If you're interested, we're actually working on a more secure cloud platform called Mirage OS, which is what we call a unikernel. And the idea of unikernels is that we secure the cloud's virtual machine service much better than current cloud because we don't actually build a Linux stack on top of a hypervisor. We actually build only the service you want. And it's written in OCaml and verified. So if you're interested in that stuff, then talk to me later in the break, because we think that helps a bit. There's another trick you can do, which people also alluded to yesterday, which is you might want assurance that the cloud data center managers can't get at stuff. But unfortunately, of course, the normal structure of privilege is you have the hardware privileges, which then the hypervisor runs at the highest privilege level, the OS at the next one, and applications on that at the lowest, right? So your privilege is so the guy that runs the data center has got super user, supervisor privileges, can get at all the memory of anything from the hypervisor. How about we invert that privilege hierarchy? And you can do this. You can run stuff in different trust zones, ARM or SGX on the Intel, or you can have a system which actually just reverses the privilege. The hypervisor just manages CPU resources, but actually can't look at memory in the guest OSs. That's doable. People have built systems that do that. We have a hardware infrastructure built of our own, which uses capabilities for managing that. It's a little bit complex. If you're interested in that, Cherry is funded by DARPA. And that would let you reduce the risk that an insider who happens to have access to managing all these compute resources in the data center could look inside these guest services. That would seem like a good practice if you can do it as well, right? So there's several different techniques there. Again, we heard about a couple of those yesterday, so that's all good. So I've mentioned that. And then obviously, kind of two other things I've obviously mentioned. I'm not going to go on about crypto, we've got far more expertise here than I have. But I think routinely having everything stored encrypted to save you from yourself, everything transmitted encrypted to save you from the mafia, or just script kiddies, and if possible, as much processing done on encrypted data as you can possibly get away with, and more later, as people speed it up. That seems like a good way to go. Okay. Now, I realize that law enforcement agencies will get upset about this. Yeah, and I'd like them to come back and say, show me when you caught somebody as a result of surveillance. Then I will listen, and tell me what you're prepared to spend to do this properly. Okay, so encryption, of course, the main problem with encryption is key management. Let's not go into that. There are horrible problems with normal users managing authorization access control technology. Even understanding public key crypto is beyond most people. Okay, the last thing I mentioned is something we built in our cloud platform, which is information flow control, which basically is tagging data. And the idea here is to help with enforcement and detection of location of data and processing. So basically you have you tag any data. The system we built is a kind of prototype for the health service, where you tag data saying this is going to stay inside this country or this jurisdiction, and the tags can be checked as they flow through any communication channel that you're staying within the right zone. And the tags are immutable. So how do you do immutable tags for information flow control? Well, you have to trust a low level. So you have either some trusted computing part of your platform, or you believe that the operating system is secured in some nice way because it's verified and you can't break that, and you can check what you booted. So, or both will be good too. So IFC, we didn't invent any of this. These are all things that people have built. Lots of groups have built IFC, and it seems like one should do this anyhow, right? Because, as I mentioned at the beginning, this is our project, but many people think that in the end, these are not going to be all technical solutions. At some point, things go wrong, and you need to appeal to a legal solution or a regulatory solution. And at that point, you would quite like to have evidence about things. And so having audit trails about where stuff went, provenance of where it came from, seems to me to be like absolutely necessary, particularly in where data is really sensitive. It's not just my birthday or my Facebook page, but it's actually my health record or criminal record or tax record or whatever. We want to know that this has only gone to the relevant places, or it's been expired properly because it's not supposed to be known anymore, right? If I move country, I don't want the health service in my old country to have the record. I want to move to the new country and to be deleted in the old country. And obviously we can't prove they've been deleted, but I'd like to know that that I could detect if somebody magically resuscitated access to that record. So IFC might be a component there. Okay, so yeah, so the result of all this work is what we've been doing is we kind of had to think about, could you do an EU-only cloud? From a legal perspective, the lawyers actually said probably not, by the way. The problem is within the EU there are 31 different data protection jurisdictions. And there are companies, HP for example, will sell you a tool. If you're just doing an HR records system for managing who works for your company or your institution, who gets paid by whom, and you have people working in other countries, you have to make sure that your database conforms to all 31 different laws. And that in itself turns out to be beyond humans. So there are now tools that will do that for you. And that's just a simple case. That's not even including stuff that is really sensitive, right? It's just like who works for you and is paid by there, right? There's personal information and there's HR record will have your bank account information when you pay them and so on. So you care about it, okay, so the legal perspective, you probably can't do this, but you might be able to do it the other way around, which is that people just agree the jurisdiction applies for the service they're running. And that doesn't defend you against GCHQ or the NSA, but they're a threat that is like beyond sanity. Let's just deal with the stuff that really matters, which is credit card loss or embarrassing loss of information or possible loss of life through privacy invasion, revealing abused spouse location, all those kind of horror stories. And then, of course, all these techniques can also just be best practice. So we've already seen a good impact from just having the Snowden story out there, which is not that you can stop the NSA and a secret recorder, but that actually having everything encrypted on disk and then transferred between data sets and to the user, maybe client-side crypto, is a good idea. And securing the browser and the operating system on mobile devices is also a good idea. So they all seem to be very sensible things to do. Basically there is an issue with this, which is the US has pleaded this kind of specialism, that they have this special privileged position in the world, and I think what's happening is that there's more money in Europe actually than the US. So certainly, if you add in China and other places, it's not true anymore. The world is a bit more complicated than that, and sure, there are some surveillance people in some special agencies that would like to weaken the crypto system yet again. But unfortunately, that's not going to work because we have okay crypto systems. We're improving them all the time. I didn't mention we have work in progress. We've done a verifiable TLS implementation in a functional programming language. We compared our verification with Microsoft F# implementation, which they use the Coq theorem prover to check properties. So we're actually pretty sure we're going to have two really, really good systems that do not have any of the known vulnerabilities and won't have any of all the classes of vulnerabilities of those either. They could have new ones, but that will be very hard for people to exploit. They have to be much cleverer, right? Heartbleed is not going to happen again. And so there is an issue there, which is, well, the surveillance guys are going to have to come back and explain what their position is to really get access. Now, of course, that may involve getting warrants and stuff and talking to people, and God forbid, actually doing proper intelligence, gathering, listening to people in pubs and mosques. But it's a joke, you don't get the same person in both pub and mosque usually. Okay. Okay, so we just had a very nice little IEEE workshop on this, and hopefully this is going to become a slightly bigger conference on cloud and legal matters, because it seems to be, it's not just the law, it's the regulatory side of it, and also how these things apply. So that's just a bit of advertising. We just had this last month, but there will be a follow-up to that. So if you're interested, and we have a couple of papers, like I mentioned, are on SSRN actually. This is a weird experience for me, writing papers with lawyers. In computer science and engineering, we write papers in LaTeX, and they have like references at the end. And you write papers with lawyers, and they're like 50 pages long, and they have half a page of footnotes on every page. And then you put them on these weird social science websites, because that's how they publish stuff. So anyway, that's what we did. Okay, I'm finished. That's the end of my talk. Any questions?
Yeah, I guess there's lots of opportunities for questions, so let's start with Ashoka.
Okay, so but thanks for the talk, inspiration. So you mentioned that, made it very clear that human intelligence is what has been successful, and all these misguided attempts to do internet surveillance hasn't really produced anything. Why is that? Is there something fundamental about internet surveillance that?
That's a really good question. So I think there is actually a technical answer to that, which is, it's actually a lot of big data, anti-big data talks recently from the social sciences have pointed out. So big data I'm no problem with in astronomy, in particle physics, probably in genomics, a whole bunch of things. But when you do it on social data, you have this incredible false positive rate, and as you increase the dimensionality of the data, all these techniques people have, very clever machine learning. In fact, we heard yesterday about even just trying to detect malware, you get this false positive rate, they kill you. They completely kill you. So if your false positive rate is like 5% on a billion people, you arrest all these people, you know, to try and prevent them, and then you get in a massive mess because then you have them, you're processing them all in. Guantanamo is not big enough for 5% of Europe and North America, right? So, so what do? So you don't arrest them, so then you miss them because you actually, some of them are the actual people you were trying to catch. So I think there's a sort of fundamental thing about
is that the current technology's limitation, or is that the fundamental?
I think it's possible we could improve machine learning techniques and keep supervising them and keep doing stuff, but I think the problem is that there's always mission creep with these organizations, which is they increase the dimensionality of the data faster. Effectively, they're looking in more and more haystacks for the same number of needles. And in fact, the analogy is not very good because, you know, it's like if you increase the dimensionality, it's like you're stacking haystacks, you know. And so I think it's actually very, very tricky. You're looking for tiny signals, and you know, turn it around. One of the big ironies is when you see discussion of ISIS at the moment, these guys are completely open. They run recruiting websites in the plane. They don't have any secrecy. That's not their model of the world, right? That's completely ridiculous. That, you know, they're not interested in that. So their cover traffic for the guys that are really the local terrorists that are really bad. I mean, they sort of talk about the policies of this, but you know, then there's this huge amount of cover traffic of an organisation that is, I don't know how you describe it. It's like, you know, for some of them, they think they're freedom fighters, right? So, and that's always going to be true. There's going to be some viewpoint under which, some dimension or multiple dimensions on which these guys are just talking to all these people in the plane, and therefore that's going to mask this thing which we regard as, you know, so. And I can't see how that's going to change. It's not obvious how you can change that. There's also the kind of how many people you need to do the interpretation, and as that number grows, you end up with a very weird risk factor. So we already know that security agencies internally have abuse of their surveillance systems. That rate will go up, and I already mentioned that in a well-motivated organization like our health service, or actually our police force. We have on the order of once a week an event where somebody uses a police database to find out something about somebody and sells that information. And you know, this is not that lots of people are bad, it's just that when you have 250,000 people doing something, one of them is going to be two of them. You know, what is it, 1% of the population are psychopaths, right? So,
Silke has something.
Yeah, you, in 26 and some other points you showed about basically about routing security. Are you also looking into improvements for the routing table updates and border gateways?
That's a great question. There are people doing this. It's not my area of work now. One of my colleagues.
You were showing this kind of Schengen routing there.
Yeah, one of my colleagues, Tim Griffin, has worked on meta routing, which is an attempt to do policy routing, which is more verifiable. But currently, the real mess is that BGP uses the tool we have is so complex in practice that I really think it's very hard. And then even just securing, you know, BGP-sec, just securing the protocol itself is horrible. So I'm not up to date on that, but I mean, I know people that work in that space, you know, realize that it's important to fix just to make sure the network stays alive, let alone fixing this kind of problem. And then if you go one step further, which is if you want to keep data flows jurisdictionally aligned with some geographic area, you need to have geolocation, and that's not 100% effective. And should a network provider be able to do geolocation 100% effectively, that's not obvious at all, so they should be allowed to actually. So you know, the cloud provider might want to know where the far end is, but if it's only the network that can tell them, the network's not supposed to be able to report that to other people, that represents a bit of a non-fixable part of the equation there.
Yeah, the Russians have some law for that they want to take into next year. Practice. I don't see how they want to do that.
I mean, that's interesting. You can turn that question around. We've done some work on censorship, and in fact, with Pakistan, they actually have quite sensible government with regard to censorship there. They just want to stop offensive stuff. and they're quite open about it. We have their blue code configurations, and we work with them. And the reason they want to do that is they're excessively censoring accidentally because the tools are too crude, and they're blocking sites. They're actually legitimate local companies putting up videos about their business, and they don't want that. They want the business to be able to do that. They're embracing the internet and stuff. And so, we have examples where the tools aren't good enough by a long way, and they're already breaking businesses, not particularly bad reason. It's just an accidental overreach side effect, not one. But yeah, there's lots of gaps in the system.
Other questions, Thomas?
So, unfortunately, I'm not convinced by this argument that false positives make this huge data collection useless. So it's true that if you start mining the data with no ideas in mind, you will produce 5% of people as false positives. But if you start from human intelligence and you want to confirm that, or you want to pick more data, it must be very useful for the FBI, for example, to be able to pull once they suspect you, to be able to pull your communication history and past phone calls and listen to them later, after the fact. All that on record forever.
Yeah.
And another thing that these intelligence agencies will need is they need ammunition against people. So once they need to, maybe not you, but some Russian guy or Iranian guy, once they know personal facts about those, they will use it.
No, I didn't mean to imply that wasn't true. There is evidence that's been used in court that was gained from surveillance after they caught somebody. When they got these human intelligence to figure out this person was a likely suspect, they arrest them, they then go off and trawl through various devices and they get the data. And it's clear that if you've got directed ways of doing that works. And there's possibly a sort of intermediate stage at some point where you are gathering everything. The problem is, if we are running a secure net for the purpose of preventing accidental loss of credit card, health record, blah, 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 which could cause loss of life, accidentally or through normal criminal behavior rather than terrorism, then they can't routinely decrypt all that stuff. That's just not going to be possible. I don't see how there's a compromised position on that. There's a large number of people who, having keys escrowed on a per service basis with someone might be okay. So I wouldn't mind my bank being able to recover my keys for internet banking, and my doctor be able to recover my keys for health monitoring on me and whatever. This all seem reasonable. And then if a government agency goes and talks to them and has some magic for doing that, that might be okay.
But it's not always a question about what is reasonable from a kind of civil rights or
No, I understand.
libertarian point of view, but what is useful. Because your argument was this is not useful for the intelligence agency, and they can do things that they don't know what they're doing, they don't present their evidence before. It's a part of the internal process.
Yeah, but
they will do things that are illegal in that country.
Sure, but the whole thing is, as well as anyone, it's an arms race. So if people know this, they will change their behaviour, so it will become less useful. So, people will just start to use spoken code books or whatever, and they won't use crypto, and you won't be able to tell. You decrypt all that stuff, and it doesn't mean anything to you. It's just quotes from a 150-year-old book, Alice in Wonderland, in the middle of a sentence that means something to the other person. So I think it would, The other thing is quantify the usefulness to that agency. What value did it have to society? Like I said, there's at least one plausible estimate that the spend on that system is running at a crazy level compared with just saving lives from cars and planes.
That argument has to come from this, that the damage is so big.
Okay, let's give a chance to Vesa.
I was wondering that have you considered adding some kind of market mechanism of information to your secure cloud? Because you mentioned that if you would pay $3, then you could get it sort of ad-free.
Yeah.
So could you sort of reverse that? I as a consumer would sell my information to this.
We actually have a project which a couple of people here know about, which is an IoT project in the UK, where we're explicitly saying with IoT data, it's so personal, if you're looking at the smart home, that the only way to do this is not put it all in the cloud, put it into a personal, secure cloud, and then you still want to have useful things done with the data. So optimize your energy use in your home or whatever. So you kind of go, okay, I'll sell this data to utility for a fairly small discount on my electricity, or I'll sell it to my shop, in exchange for loyalty points with the shop. relevant pieces to relevant people. So you create a market in personal information, but with specific customs for it. And you do this possibly through an aggregator that's a differential privacy preserving aggregator. So you minimize risks. I think there are lots of ways you could do that. And I think that's figuring out how to make that succeed is interesting. You know, that we have this dominating world just for the last 10 years, that this simple two-sided market has emerged of the advertising way of paying for things. There's at least one area where that's shifting, which is in entertainment, where everyone was doing either peer-to-peer for free, stolen music and films, or getting stuff off YouTube, but having to put up a lot of adverts. Now, we have a lot of subscription services like Netflix and that you pay for, and you don't have to have ads. You can go to a level with some of the music services where you subscribe with no ads, you pay a bit more. So they've already created a world where that's happening. You can add back in privacy preserving recommendations as well. You can still do that. In fact, yesterday there were people talking about that as a service. And I think then you have a different world because you've created a spectrum of different market solutions. And then people can pick, you know, how sensitive am I about my privacy or my wasted time looking at ads? And I pick a point on that scale, and then I pay more explicitly in money or time. I think that would be a...
Do you think that this will then offer a solution for this legal problem? So if there would be always a commercial contract?
Well, yeah, I mean, that was what when we did the reports, we had a workshop in Cambridge with a bunch of people from cloud providers and companies. A lot of them were like, that was their view, was that if you do a contractual solution, we get away from all this, and that's makes everyone happy because they understand how that works already. Bringing in some new complicated law that says you must have a German-only cloud, and trying to figure out how you get that affordably done. Actually, you know what the view was from some people on that was that this was just an attempt. I've heard this in England and America. It's just an attempt by some countries to build a set of companies within their own country that have competence to do this. And that's not the way to do it, right? If I'm creating a walled market for your own people, it's a daft idea, a crazy idea. If you create incentives for people to do something new, what you said actually, create a market of different choices would be a better way of doing it, because then people could come along and pick a point in that market to build a new service. If they're smart, they create a successful business. It could be IoT, cloud that does privacy for this amount of money and does aggregation. You get money back for these different bits of information. That would be a new business. So, and there are people certainly here that are doing that kind of model. So I think I would encourage a sort of positive way out of this in those directions rather than a legislation way out of it.
There are also startups that are trying to do similar things.
Yeah.
In the valley, like data.
Quick question from John.
Maybe stupid. Is it able to split the responsibility to several clouds? We assume the clouds cannot collude with each other, or a subset of clouds cannot collude with each other, and they work together to provide service to the users. Is it able to do that?
So I'm not quite sure what the question is. That you have a cloud for each of these different services, and then you combine them together where?
For example, if they want to provide a routing service,
Yeah.
but one cloud cannot provide that, but we split
Oh, I
the
see.
task to several clouds.
Right. So you want, I totally, this is a kind of more radical approach where you effectively diversify the service so that no single, so this is something we built an example of this for storage, like an equivalent of Dropbox, where you code your files over multiple, you do block level coding of multiple files over multiple storage service providers, and no single one of them can recover your file.
Yeah.
So I should say that Microsoft actually liked that solution. They're actually talking about if they can't get out of this situation with this court case in New York and Europe, they may actually move their Azure service to doing storage that way, so they can then say to the judge, we cannot give you the data because we don't have it. So some of the data is on a different company that's not US based, and you can only recover the files by combining the data, and we don't have the access. So that's an interesting idea that the earliest I've seen of that was Ross Anderson wrote a paper called The Eternity Service 15 years ago, which kind of had that idea, I think, in it. And we certainly have coding techniques that could do that, so that you need to effectively coerce multiple providers to be able to recover recover stuff. That would be interesting. It doesn't work for the processing and analytics side. I mean, the person running the analytics tools retrieved all that data. Now they've got it. Maybe there's a solution for that as well. Actually, some sort of network-coded processing.
Can also done by crypto approach, such
Yeah.
as sharing.
Yeah, but those are expensive, right? So, yeah.
Okay, I think we are done with this session. So the rest of the questions during the break, so go